Hello students, welcome back. Today we are going to discuss class 11th mathematics chapter 1 sets. We will discuss today the proof of De Morgan laws. The proof to this De Morgan laws we are not going to discuss through some examples through taking some sets and through Venn diagram. We are not going to do that. We are going to do it purely algebraical solution. This is one of the pet questions of the CBSE examiners. Before going to this video, don't forget to watch my video on algebraic approach to set related problems. I have discussed in detail how to solve set related problems algebraically. As we discussed before, De Morgan's laws are A union B complement equals to A complement intersection B complement. Second one is A intersection B complement equals to A complement union B complement. See, to prove these laws, our approach should be we'll prove this first set is the subset of second set and the second set is the subset of the first set. That we have discussed in the previous video. This is, in nutshell, this is the thing. To prove A is equal to B, we prove A is a subset of B and B is a subset of A. Then it follows A is equal to B. This is what we did in the previous video. I explained in detail about that. We are going to do the same thing in De Morgan laws proof here. Before going to that proof, I'm going to discuss these important points for the proof. This also I discussed in detail in the last video. Please do visit last video and have a thorough understanding about this. All the concepts and are given in that. You will be very comfortable in solving this problem. It will be very, very easy to solve these problems if you understand that. And again, I am just repeating it for your convenience. Suppose in union, if X belongs to A union B, X belongs to A or X belongs to B. And second one is if X does not belong to A union B, then X does not belong to A and X does not belong to B. This is when union does not comes and union is there, you will get AND here. X does not belong to A and X does not belong to B. In intersection, if X belongs to A intersection B, X belongs to A and X belongs to B. Intersection AND. Intersection is there, AND comes. If X does not belong to A intersection B, then it becomes R. When intersection is there, does not belong to is there, it R comes in between. X does not belong to A or X does not belong to B. These four important rules you should remember. This follows from the normal understanding of the set. If you see Venn diagram, from Venn diagram also you can understand, you can easily visualize all these things. These are the basic things. But remember this, understand this and remember them. Union B, or comes. Intersection and is related. Does not, when it does not belong to union is there, and comes. It does not is there, intersection is or comes. Okay, that's the thing. This is also useful. This is very important. If X belongs to A, X does not belong to A complement. Of course, it is very obvious, right? If X belongs to A, X does not belong to A complement. It's obvious, right? X belongs to A means, and X A complement is what? Leaving out all the elements of A, remaining elements of the universe, A complement. So X does not belong to A complement. If X belongs to A complement, the other way around. X does not belong to A. In the next slide, we'll straight go into the proof of the De Morgan's first law. This is the first law. A union B complement equals to A complement intersection B complement. This is what we have to prove. This is the one, right? So will our approach will be similar for the both the laws. Now follow the first. We'll follow like this. Let an arbitrary element X belongs to A union B complement. First thing is this, right? Then what we are going to do is remove this complement. Complement to remove A, we have seen this, right? A, X belongs to A, X does not belong to A complement. That's what we have seen, right? Or then when X, this is what we have to use it here. X does not belong to A union B. If we remove the complement, does not belong to comes. Obvious. It's clear, right? So X does not belong to A union B. Next one. X does not belong to, this is a union. You can write, and because you have seen this, X does not belong to A union B means X does not belong to A and comes here, and X does not belong to B, right? This is what we have written here. So this X does not belong to A means X belongs to A complement. Is this clear? X does not belong to A means X belongs to A complement, and X does not belong to B means X belongs to B complement. Clear? This is so far so good. Step by step we will understand this. It is very easy. If you understand the concept, it is very easy. But this is very important. But in the examination point of view, this is very important. Now next step is X. From here it follows what? Implies X belongs to A complement intersection B complement. X belongs to A complement intersection B complement. This is the implication. Therefore, this is A complement intersection B complement is nothing but this one. So, what is this? We started with first set. X belongs to A union B complement. Finally, proved that X also belongs to A complement intersection B complement. We started with X belong to the first set, and we finally proved that X belongs to the second set. So this first set is the subset of second set. So A union B is a subset of A complement intersection B complement. Now we'll do what we have to do. We have to do this second set is the subset of first set. We have to prove that. Now let another arbitrary element y be an element of A complement intersection B complement, second set. So that implies what? Y belongs to A complement and Y belongs to B complement. Then Y does not belong to A complement. We have to remove these complements, right? Right? We have to remove this complement. That means we have to Y does not belong to A and Y does not belong to B, right? Then this is what Y does not belong to A and Y does not belong to B means what? Y is does not belong to A union B. We have seen this, right? In the before beginning, the same one. The same one. Here we are taking Y arbitrary element. The same thing. So Y does not belong to A and Y does not belong to B means Y does not belong to A union B. Got it? This is means this is the only thing you have to make a note of it. Next is Y does not belong to A union B means you have to remove does not belong to. Y belongs to complement. A union B complement. You have to put a dash. That Y belongs to J. That means A union B complement is what? The first set. Right? This is the one. Right? So we have started with the second set. Y belongs to A complement intersection B complement. And finally, we proved that Y also belong to A union B complement. This is algebraically proving that. So A complement, the second set, A complement intersection B complement is a subset of A union B complement. Second set is a subset of first set. So we have proved from this, you can say this is one, and from this you can say this is two. From 1 and 2, we will get this first set is equals to second set. This is proved. This is the way you prove De Morgan law. Be thorough with this. Till you understand, you have to do it. Once you understand that, it is very easy. Focus on the three concepts I told before. In the next slide, we will be doing the second law of De Morgan. Now we'll prove the second De Morgan's law. Second law deals with the intersection of sets. So we'll have the similar approach. So let X an arbitrary element belongs to A intersection B complement. We have to prove, as usual, we have to prove these two sets are subsets of each other. First set is subset of second set, and second set is subset of first set. So let X be an arbitrary element belongs which belongs to A intersection B complement. That implies what? X does not belong to, we have to remove this complement, right? We have to remove the dash. X does not belong to A intersection B. We remove this complement. We write does not belong to, right? So next is X does not belong to A or X does not belong to B. When does not belong to is there, intersection is there, then or comes, right? X does not belong to A or X does not belong to B. That means what? Again, we have to remove this does not. F belongs to A complement. You does not remove that. That means we have to take this X belongs to A complement or X belongs to B complement. Right? Then what is this? By definition, X belongs to A complement or X belongs to B complements. A complement union of B complement. X belongs to complement union B complement. So we have started from X complement A intersection B complement that it X belongs to that. And we proved that X belongs to A complement union B complement. So first set is the subset of second set. Now we'll go to the other side. Means B will prove this set is second set is complement of the first set. Let an arbitrary element Y belongs to A complement union B complement. This implies Y belongs to A complement or Y belongs to B complement. Here the complement is there. The next step is you have to remove that complement. For that what you should do? You know what you should do. Y does not belong to A or Y does not belong to B. Okay, Y does not belong to A or Y does not belong to B. So does not belong to A or is there. Does not is there or is there. So what it comes? Intersection. So it implies Y does not belong to A intersection B. So what you have to do? This does not, you have to remove. Y belongs to, you have to write. So Y belongs to A intersection B complement. So Y belongs to A intersection B complement. This is what? This is the first set. we started with Y belongs to A complement union B complement, and we proved that Y belongs to A intersection B whole complement. That means second set is the subset of the first set. So A, therefore A complement intersection B complement is a subset of A union B whole complement. From 1 and 2, we proved that the first set A complement intersection B complement equals to A union B complement is proved. So that concludes the proof of De Morgan law algebraically. This is very important. I reiterate, I stress that understanding of this will go a long way in solving the miscellaneous problems and much tougher problems, which are actually usually asked in the examinations. You'll be well equipped to solve those problems. All the best.
I just wanted to show you this De Morgan's second law can be proved by interchanging union with intersection and with OR. The subsequent proof follows for the first set subset proof. A part of that I shown that in the next slides.
That means we can prove this by just replacing, replace intersection, replace union with intersection, and replace or with and vice versa. Here also vice versa. Okay, that means if union, if intersection is there, you replace with union. If and is there, you replace with R. Okay, that is fine. So this is the De Morgan's second law. We have proved this intersection. Here I copied the first law's solution. Wherever union is there, replace it with intersection and with or intersection with union.
This proof of first set to second set only I am showing. The other one proving second set as subset of first set you can do on your own. It's simple one.
Next, in the next video, I wanted to discuss miscellaneous exercise problems.
Hope you understood the concepts and solutions well. Don't forget to watch introduction and solutions together for each exercise. Please like and subscribe and share with your classmates and friends to get all the videos of the channel. Thanks for watching. See you then.